Hello, fellow scientists, and welcome to a continuation of our antibiotic resistance 5E review series. Today we're going to be taking a look at what's pages 13 to 21 in this packet. The numbers might be slightly different in yours, but it's the section called Evaluating a Claim, Antibiotic Resistance. So let's go ahead and take a look at what we are asked to do here. So for this activity, the end result of this is going to be a paragraph where you basically support this claim. How have bacteria, question rather, with a claim. How have bacteria become resistant to antibiotics at the population level? So the first thing that you need to do, which goes along with the first part of this, is watch a video. It's called Antibiotic Use in Agriculture. I have the video posted on Google Classroom underneath antibiotic resistance files. And in there, you'll see the trouble with antibiotics. And you'll need to watch at least the first 20 minutes of that video, although I encourage you to watch the whole thing. So from that video, we come back to this and it says, well, what were evidence that support the claim, right? It says at the population level, antibiotic resistance is being used or is being caused by the overuse of antibiotics in agriculture. And so there was really three main pieces of evidence to support this. The first piece of evidence was that 70% of antibiotics are used in agriculture. The remaining 30% are human use. So 70%, the majority of antibiotics are used in agriculture, evidence one. Evidence number two is that we see an increase of resistant infections near farms. And so the idea, and I'm going to leave that word out there for now, the idea is that something is causing resistant bacteria on farms to develop due to antibiotic resistance, and that resistance is somehow passing on to humans. So once again, the two main pieces of evidence from the video are that 70% of antibiotics are used on farms. So there's a lot of antibiotic use on farms. And the resistant bacteria that results from that antibiotic reuse is somehow transferring to humans. So the second piece of evidence is that more people are being impacted or infected with resistant bacteria when they live near farms. So then it says, well, what refutes that claim? If that's what certain people are saying, that the resistant bacteria that are being evolved or selected for on farms are passing into human populations, what evidence refutes that? Well, there's one primary piece of evidence, and that is that there is no direct scientific link, meaning we haven't seen somebody in a hospital that got sick that we can say bought this meat from this store, which goes back to this farm, which was applying this antibiotic, and we see a clean transmission pathway. It just hasn't been seen in the research. Doesn't mean it doesn't happen, but there is not a direct link that has been observed. So what exactly is happening here from the video? We're going to model this. So the cause is overuse of antibiotics, or maybe just say use of antibiotics on farms. Right? That's the starting point of any potential problems, is that there's antibiotic use on farms. So why are they doing this? Well, in the short term, that gets us cheap food, and it gets us more food. Okay, it keeps the birds safe, keeps the pigs safe, and that lets us have cheaper food. It lets us have more quantity of food. But the long-term effect is that it also creates antibiotic-resistant bacteria for all of the reasons that we've seen in class about natural selection, right? If you apply massive amounts of antibiotics to a population, some of those bacteria will be naturally resistant to it. They are going to survive, they are going to reproduce, and over time, the population becomes more resistant to the antibiotics. The counterclaim, once again, this idea, no direct observable evidence. We'll see that one more time after this. That's the only real counterclaim to this. It is 100% observed. The effect is real. We're not sure of the mechanisms that are causing it. And that is, in fact, the counterclaim. The counterclaim is we do not know the direct link to these increased infections from these resistant bacteria. So there's two words that we use here, cause and correlate. And this is like science language. So we just want to be careful about what we can say is a direct cause versus what is simply related or correlated. So for a cause, I would say, and we can say this definitively, antibiotic use on farms causes more resistant bacteria. 100% true, 100% verifiable. We know that happens. Once again, I can say antibiotic use on farms causes antibiotic-resistant bacteria to form. Now, what I can't say is like antibiotic use on farms causes people to get sick. That's what we don't have a link for. But we can say that that's correlated. Okay, so what I can say is that resistant infections are correlated with living near farms, right? We see people that live near farms tend to have more of these resistant infections. That is a correlation. Notice I'm not saying that living near a farm causes it. It might not. We don't have a direct link, but there is definitively a correlation, meaning people living near farms are more likely to get these resistant infections than people that don't. We can see that in the data. We don't know the reason why. But we do know the reason why resistant bacteria are formed, going back to our cause, and that is the use of the antibiotics in the first place. So causation versus correlation, just being careful in how we use those words. So from there, there's a short reading. I recommend you pause, take a minute to read through this. Specifically, you have a section on agriculture, which will come back in a paragraph in a minute, and a section on caves, which is also going to be important. So here we have a chart, and I actually want to go to a document somewhere. Where's that at? Oops, not there. Maybe not. So this particular chart is going to walk you through sort of the process of 3 scenarios of natural selection. And it's showing how all scenarios have the same basic steps or components, right? They all have variation. They all have pressure in the environment. They all have some adaptation from those variations that does better, right? Which leads to survival, which leads to an eventual change in the population. So I'm going to be working across these boxes, just talking about sort of those different categories. So let's start with variation. So in our mice, the variation was light and dark fur. In terms of, actually, I think this one was in caves in most of your packets. I'm going to change that. In terms of the cave story, the variation was resistant and non-resistant bacteria. And then in terms of agriculture, it is also resistant and non-resistant bacteria. And that resistance refers to antibiotics specifically. Now we'll see that although these are the same traits, they evolve for slightly different reasons. And we'll see that. So then it says, well, what was in the environment that was putting pressure on the population to survive? In the case of the mice, it was predators. Right? Predators are constantly hunting the mice, which puts pressure on them to survive. What is it in the caves? In the caves, it was described as biological warfare. These bacteria are fighting over a very small amount of food and resources that exists in these caves. And so they're doing warfare, trying to kill each other all the time. And then the environmental pressure in agriculture is the farmers using antibiotics to keep the birds safe, to keep the pigs safe, to keep everything safe. So it's the farmers using antibiotics, specifically the antibiotics, but the farmers are applying it on the farms. So then what trait adaptation is helping this pressure? Well, in the case of the pocket mice, it was camouflage. Right? So having camouflage is an adaptation that can help mice survive, which is going to tie into different colors being better, so on and so forth. In terms of biological warfare, having resistance to antibiotics, once again, is going to help survive. And then also on the farms, having resistance is going to help because that's going to help survive the medication that's being given to the animals. Once again, we're talking about the bacteria here. So then differential survival. So what happens? Well, the black mice survive, right? They're the ones that have the camouflage to survive the predators. So the black mice survive more. Differential survival means that some traits survive more than others. So the black trait survives. In the case of biological warfare, resistance survives, right? It can survive the attacks from the other bacteria. In the case of the farm, the resistance trait survives because all the medicine goes in all the chickens, but some of these chickens have bacteria that are resistant, they survive. So then how does that change the population? Well, very simply, it's like it creates more black babies and more resistant offspring and more resistant offspring as well in the farm. So they just create more of those surviving traits when they reproduce, and that causes a change in the population. So now you're going to be writing a paragraph that sort of summarizes a lot of what we've said. Now you have two options for how you set this up. You can either kind of come up with your own, okay, which you would write your claim. In this case, I would suggest getting data from our graphs that we did on antibiotic resistance, something from the agriculture video, something from the reading. And then you're defining natural selection and its processes, which is this column here, and talking about that. If you think you want more support over here, you can draft a final response. And for this, on Google Classroom, there is an antibiotic resistance graphic organizer, and it kind of gives you 5 sentences. So you have a claim. So you're going to write this sentence, and then you're going to choose either randomness or natural selection. But be careful because one of those is wrong and one of those is right. I would definitely just think of key vocabulary here. And then you're going to say, like, what happened in our pocket mouse simulation? So you would go back to the organizer we just did and kind of summarize this column. And then you would say second, according to the cave scenario, right? So you want to go back and kind of summarize what happened in the caves in terms of natural selection. And then finally, according to the agriculture scenario, and then summarize that story. And then your final reasoning is basically to just talk about how natural selection, which once again, hopefully that's what you chose, is at the basis of all of these stories. And that natural selection always tells the same story. There's always, and they're numbered here, variation. And that variation is affected by the environment. There's something in the environment that's putting pressure on those variations, which leads to differential survival and reproduction, which causes a change in DNA of the population. So that is what you want to do. So 1, 2, 3, 4, at least 5 sentences. And this one, you just kind of connect those together into a description of how natural selection occurs. Once you're finished with that, you'll find in your document a rubric. Right? So this is just, self-assessment. Do you think you have everything that you need? And then just a summary of some key ideas. Eventually, you'll get to the antibiotics text, and that's where you can stop. That's effectively the end of this particular lesson. With that said, I hope that helps. Obviously, if you have any questions, feel free to reach out and ask me. But for most of this, you might need to go back through the video, make sure you pause, get your notes as you go, and then just fill all of that in and bring that to class.